We're doing the last example on page 2 on logarithms. The first thing I want to do here is I want to go ahead and put this log on the left-hand side so that when I do my lean-to, I can get it right. So log base 5 of x minus 3 equals 3. And now I'm going to do my lean-to. I'm going to lean to the left, I get 5. I'm going to lean to the right, I get 3. Equals the middle, which is x minus 3. This is pretty simple.
125,
it's
right?
125, right? And then x minus 3, I'll add 3 to both sides. I end up with x is 128.
Yep.
Okay. We are going to do the, we're going to do some of the examples on page 3, but we're going to skip any of the ones that have an e for now or an ln. We're just going to stick with regular common logs for now, and we'll come back and do the other ones. All right, so that first one that says 4 times e to the negative, we're going to skip that for now. And we're going to go down to the next one, which is log base 1/3 x equals negative 3. And on this one, we're just basically going to do our lean-to. Okay? Now, first of all, let me ask you, is this a legal base?
Yeah.
It's positive, and it's not 1.
Yeah.
Just check and make sure. All right, we're going to lean to the left, so we get 1/3. We're going to lean to the right. We're going to raise this puppy to the negative 3. And that's going to equal the middle. Now, I don't know if you remember all our exponent notes, but when you had a negative exponent, okay, that's either, what you're going to do is you can take the reciprocal of this, and it becomes 3 over 1 raised to the 3rd. Okay? Equals x, and 3 to the 3rd is what? 27? So x equals 27 on that one. All right? The other way to do this is to say 1/3 to the negative 3 would be like 1 over 1/3 to the 3rd.
I'd rather do that one.
I understand, but this is what you're doing.
Okay. Yes.
And then when you do, because this is the same thing as 1 over 1, and then when you do fraction divided by fraction, you multiply by the reciprocal, so the 27 ends up on top. So just to kind of refresh, if you remember your rule with the negative, you do the reciprocal and then raise it to that power. Okay?
Okay.
I don't remember how many exponent rules we've gone over here, but since logs are exponents, guess what? Your rules are the same. It's a fabulous thing.
Good.
Okay, the next one is 10 to the x plus 2 equals 55. We do have the exponential form on the left-hand side, which is where we want it. My x is in the exponent, so we want to put it in logarithmic form. I'm going to lean to the left, and I'm just going to write log. You can put base 10, but it's from the Department of Redundancy Department. Lean to the right, get 55, equals the middle, which is x plus 2. For this one, you're going to need your lovely calculator, and we're going to plug in log 55. And I got something like 1.74036 yada 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 equals x plus 2. And then I'm going to take away 2 from both sides, so I get x is approximately negative 0.2596373 yada yada yada. Alrighty? Okay, we're going to do one more example. See where it says 2 ln x? Since that's talking about a ln, which is a natural log, which is base e, which we're going to talk about more next time, we're going to skip that one. We're going to go to the very last example, and we are on page 3. All right, so it looks like 4x squared, how's that, equals negative 8, or excuse me, 8 to the negative 2x. Okay, first thing we want to do here is we want to find, remember if the bases are the same kind of thing, we want to put these in the same base. 4 is a power of 2, 8 is a power of 2. So the first thing we're going to do is change bases just to make it easy on us, okay? So the first thing we're going to do is we're going to write this as 2 quantity squared, 2 squared, raised to the x squared. So far so good? And 8, is it an 8? I said negative 8. I wrote negative 8. There's no negative on there. The negative's in the exponent, so I apologize for putting a negative 8 there. 8 is just 2 to the 3rd, and that whole enchilada is going to be to the negative 2x. So far so good?
Yes.
Now, a power to a power, you just multiply, right? So this is a power to a power. So this is going to be 2 raised to the 2x squared. So this becomes 2 to the 2x squared. Okay. This becomes a power to a power you multiply, 2 to the negative 6x. So far, so good? If the bases are the same and your powers equal, then your exponents equal. So I can set my exponents equal to one another.
Okay.
Okay? So 2x squared equals negative 6x. And what we're going to do is we're going to rewrite this and we're going to set it equal to 0.
Okay.
Does that sound reasonable?
How, I don't get just how do you get those two exponents to equal?
Okay, if I have 2 to the a equals 2 to the 10th, then a equals 10.
Oh, okay.
Yeah,
Yeah,
it's
that
the
makes
same
sense.
thing.
That makes sense.
Okay?
Okay.
So we're going to pull this over here, and maybe we'll get it right, or maybe we won't. So it looks like 2x squared, and I'm going to add 6x to both sides, hopefully, plus 6x equals 0. And I can factor out a 2x. Would you agree? 2x times x plus, what is that, 3 equals 0. So I get 2x equals 0, or x plus 3 equals 0. So divide both sides by 2 here, I get x equals 0, or x equals negative 3. And I think I could check those, right? So if I looked here, 0 squared would be 0, 4 to the 0 would be 1. 8 to the 0 would be 1, so this one works. Okay, let's look at negative 3. What's negative 3 times negative 3? 9?
Yep.
So that would end up being 4 to the 9th, or 2 to the 18th. Okay, so let's look at that. That's negative 3 times here, that would be 6. So this one does not work. Doesn't look like it works to me. Does it look like it works to you?
Let me see. 2, 18. It does work.
To the negative 3.
What? If you 4 to the 9th does equal to the 18th.
Oh, because it's 8 to the 6th.
Yeah.
Sorry. So, yes, it does. Thank you. It should have worked. This is what I wasn't taking into account. There we go. I was just looking at this to the 6th, not to the 3 times the 6, which is the 18th. My bad. Okay? Are we all right with that? Okay. We will continue logs next time.